Hello everyone. Column chromatography is a very efficient technique for separating the components of very complex mixtures. In this session, we are going to talk about the different aspects of column chromatography and we will discuss the open column chromatography technique in more detail. In the previous session, we talked about the thin layer chromatography, which is a technique that is carried out on a thin layer of the stationary phase. That thin layer is supported by a plate, usually a pre-coated aluminum plate is used. But column chromatography is slightly different from that technique. Column chromatography is carried out in a column, usually a glass column, but it may be made up of a different material as well, which is filled with a stationary phase. The mobile phase that is used in column chromatography may be a liquid or a gas. Column chromatography, just like TLC, could also be used for analytical purposes, which means that it may be used for analysis of different mixtures, or it may be used on a preparative scale for the separation and isolation of different components of a mixture. So let's see what open column chromatography means. As the name indicates, this type of column chromatography is carried out in an open setup in the laboratory. Now, the size of that column, which usually is a glass column, depends upon the amount of sample that we are going to load into that column, or you can say that it depends upon the amount of the mixture, the components of which we are going to separate. So the height of the column as well as the diameter is dependent upon the size of the sample. So usually open column chromatography is used for separation and purification of different components of mixture in bulk. So you can isolate milligram quantities of a pure component from a mixture. Now, as we have already discussed that in chromatography, we have two different phases, the stationary phase and the mobile phase. Again, the choice of the stationary and the mobile phase is dependent upon the polarity of the sample. Or you can just say that it depends upon the nature of the sample. If you have a mixture that has highly polar components, the stationary phase that is used in such case usually is a reverse phase stationary phase, or you can say that C18 silica can be used as a stationary phase. The mobile phase in that case would be more polar, that is methanol or water or mixture of the two can be used as a mobile phase for more polar samples. But for slightly less polar solvents or samples with medium polarity, you can use polar silica as the stationary phase, and the mobile phase that is used for less polar samples or medium polar samples is a mixture of two or three or a pure solvent, usually an organic solvent like chloroform, or a mixture of N-hexane with ethyl acetate or N-hexane with acetone can be used for samples of medium polarity. Now let's see how open column chromatography is carried out in the lab. So there are certain components that you need to have to perform this experiment. The first and the very important component is the column itself. So the column that is used in open column chromatography usually is a glass column. Again, the height of this column as well as the diameter of this glass column depends upon the size of your sample, the amount of your sample that you're going to load over it. The second important component of this technique is the stationary phase. So this column is filled with an appropriate stationary phase. So for example, we are dealing with medium polar samples. So the stationary phase usually is column silica. Silica is more polar stationary phase. So it is first converted into a slurry, a very thin slurry of this silica is prepared in the solvent that you are going to use as the mobile phase. So this slurry is then poured into this column that allows all the particles of this silica to settle down. But to stop it from leaking or trickling down from the column, first you need to plug the base of this column, and that usually is done with a cotton swab. So you first insert a cotton swab here, and then you pour in the slurry, the thin slurry that you have prepared for the stationary phase, that allows the particles of the silica or the stationary phase to settle down. As soon as it settles down, your column is packed and your stationary phase is now ready for your experiment, or you can say that your column is ready for chromatographic experiment. The next step is to load your sample. So you can load your sample on top of this stationary phase. The sample needs to be prepared first. There are different methods through which you can apply your sample. A very common method is to first prepare a slurry. For that, you need to prepare a solution of your sample in any solvent in which your sample is soluble, and then you apply this solution on some amount of silica, allowing the solvent to evaporate. That leaves the components of your mixture adsorbed on that silica or on the silica particles. Then you crush them to powder form and apply that powder, or pour in that powder on top of the stationary phase that you have already filled in to your column. Another procedure for applying your sample is to prepare a solution of your sample, and then you apply this sample on top of the stationary phase with the help of a dropper. That is another method that may be used in some cases. So once your sample is applied, the next step is to add your mobile phase. So then you can pour in your mobile phase. That depends upon the polarity or the nature of the sample that you're going to separate in this experiment. The next component that you need is a collecting vessel. Of course, you have to open this valve and you adjust the flow rate so that the solvent system or the mobile phase that you have applied on top trickles down from the column dropwise with a proper flow rate. It should not be very fast, or it should not be extremely slow. So an appropriate flow rate is set for this column chromatography experiment, and you collect fractions of your eluent coming down from the column in this collecting vessel. Now, column chromatography can be carried out in two different ways. This technique could be isochromatic, which means that the polarity of the mobile phase remains constant throughout the experiment. So in an isochromatic column chromatography, you do not change the polarity of your mobile phase. It remains constant throughout the experiment from start to end. But you can also run your column, or you can also elute your column with a gradient polarity, which means that the polarity of the mobile phase changes gradually during the experiment. Usually, in a normal phase column chromatography experiment, when your stationary phase is more polar, you apply or you use a solvent system that is of medium polarity. And if you are going to perform a gradient column chromatography experiment, the polarity changes from low polarity to high polarity. But if you are performing a reverse phase column chromatography where your stationary phase is less polar, then because your solvent system or your mobile phase has to be highly polar, the gradient is from high polarity to low polarity. So that is the difference between the two. Again, if you are performing normal phase column chromatography, the first component that comes out of this column would be less polar, followed by the components with increasing polarity. But if you're performing reverse phase column chromatography, then the more polar components will elute first, followed by the lesser polar components of the mixture. So this is all about open column chromatography. We will talk about some other techniques which also come under the same heading of column chromatography in the upcoming lectures that include the most sophisticated techniques such as HPLC and gas chromatography. So thank you so much for now. Stay tuned.